Have you ever gazed at the night sky and wondered where stars come from? Deep within the cosmos lie stellar nurseries, vast clouds of gas and dust where the magic of star formation takes place. Today, we'll journey through these incredible regions of space to explore how stars are born, grow, and eventually die, shaping the universe around us. These nurseries are not just beautiful cosmic phenomena. They are fundamental to understanding the life cycle of stars and the evolution of galaxies. From the delicate processes that lead to their birth to the powerful forces that shape their futures, we'll see how these regions give rise to everything from our own sun to massive giants that outshine entire galaxies. This exploration will illuminate not just the birth of stars, but also the very origins of the elements that compose our world and ourselves. Stellar nurseries, often found within giant molecular clouds, are primarily composed of hydrogen, helium, and a variety of other trace elements and compounds. These clouds can span several light years, becoming the densest regions of the interstellar medium. Remarkably, some of these molecular clouds are vast enough to contain enough material to form hundreds of stars. Regions like the Orion Nebula and the Eagle Nebula serve as prime examples of these stellar breeding grounds, where the conditions are ripe for star formation. The beauty of these nebulae, with their vibrant colors and intricate structures, is a testament to the dynamic processes at work within. Each filament and dark patch tells a story of gravity, pressure, and the delicate balance of forces that govern star birth. The journey of star formation begins with the gravitational collapse of dense regions within these molecular clouds. Picture these clouds as vast oceans of gas and dust, teeming with potential. Under the influence of gravity, areas of higher density begin to pull in surrounding material, leading to the formation of clumps within the cloud. This process can be triggered by various external factors: shock waves from nearby supernova explosions, the collision of different molecular clouds, or even the shock of star formation itself. As these regions collapse, they become increasingly hot and dense, setting the stage for the birth of new stars. The interplay of pressure and gravity creates a fascinating environment where the potential for new life is born, setting off a chain reaction of events that will ultimately give rise to brilliant celestial bodies. As the core of the collapsing region contracts, it transforms into a protostar, a fledgling star still in the early stages of its life. During this phase, the protostar is often surrounded by a rotating disk of gas and dust. This disk plays a crucial role, not only feeding the growing star, but also providing the raw materials necessary for the formation of planets and other celestial bodies. The protostar phase can last for millions of years, and as it accumulates mass, the temperature and pressure at its core continue to rise. Eventually, these conditions reach a critical point where nuclear fusion can ignite, marking the birth of a new star. This moment signifies a new chapter in the cosmic story, transforming a cold ball of gas into a radiant beacon in the night sky. Throughout this process, the surrounding environment plays a crucial role. Stellar nurseries are often home to numerous protostars at various stages of development, creating a vibrant tapestry of light and motion. Some regions may host young stars that are only just beginning their journey, while others contain more mature stars nearing the end of their life cycles. Observing these regions provides valuable insights into the conditions that lead to star formation and the factors influencing the characteristics of new stars. The dynamic interplay of gravity, temperature, and chemical composition creates an environment ripe for creativity, where new stars are born and older stars enrich their surroundings with the elements forged in their cores. But not all stars are destined to become the same. The initial mass of a star at birth significantly influences its fate and life cycle. Massive stars, for instance, burn through their hydrogen fuel rapidly, leading to short lifespans that end dramatically in supernova explosions. These cataclysmic events not only scatter heavy elements throughout the universe, but also trigger further star formation in nearby regions, creating a beautiful cycle of birth and rebirth. Conversely, smaller stars, like our Sun, have longer, more stable lives, often lasting billions of years. As these stars evolve, they contribute to the interstellar medium through their deaths, enriching it with heavy elements that become the building blocks for future stars and planets. This cosmic recycling is essential for the continuous evolution of the universe, ensuring that the ingredients for life are always being forged and spread across the cosmos. The incredible cycle of stellar birth, life, and death is central to the evolution of galaxies. Each generation of stars enriches the surrounding gas with elements forged in their cores, setting the stage for the next wave of star formation. It's a cosmic cycle that has been ongoing for billions of years, with each new star contributing to the galactic landscape. In essence, we are all made of stardust, elements that were once part of stars that exploded and spread their materials across the universe. This connection between stars and life is profound, suggesting that the very atoms in our bodies were forged in the hearts of long-dead stars. Modern astronomy has equipped us with powerful tools to study these stellar nurseries. Telescopes like the Hubble Space Telescope and the James Webb Space Telescope allow us to observe these regions in unprecedented detail. By capturing different wavelengths of light, we can penetrate the dust and gas that often obscures our view, revealing the intricate processes of star formation happening in real time. Observations in infrared and radio wavelengths can uncover hidden protostars that are still in the early stages of development, providing us with glimpses into the very early moments of stellar life. The ability to study these distant regions allows astronomers to piece together the complex history of our universe and to understand the environmental conditions that give rise to stars. Some of the most famous stellar nurseries include the Orion Nebula, located just 1,344 light-years away, and the Carina Nebula, known for its stunning pillars of creation. The Orion Nebula is one of the closest regions of massive star formation to Earth, making it a prime target for astronomers. These regions are filled with young, hot stars that are still in the process of forming. The light emitted from these stars ionizes the surrounding gas, creating breathtaking colors that we see in images captured by telescopes. Such regions are not just beautiful to look at. They are also vital to our understanding of how stars interact with their environment and how new star systems are created. The life cycle of a star is a grand narrative that unfolds over millions to billions of years. From the initial gravitational collapse to the stable main sequence phase and eventual death, each stage contributes to the cosmic tapestry of our universe. As we study these processes, we gain deeper insights into the fundamental workings of the cosmos and the forces that shape our reality. Every star is a chapter in the story of the universe, and stellar nurseries are the prologues where it all begins. Understanding these processes not only satisfies our curiosity, but also reveals the delicate balance of forces that have been at work since the dawn of time. Looking forward, the study of stellar nurseries is poised to answer some of the most profound questions in astronomy. As we discover more about these regions, we learn how the universe creates the conditions for life and how stars, like our Sun, have shaped the development of planets. The James Webb Space Telescope, with its advanced infrared capabilities, is expected to revolutionize our understanding of star formation by peering deeper into the cosmos than ever before. By analyzing the chemical compositions and structures of these clouds, scientists hope to uncover the secrets of planet formation and the potential for habitable worlds beyond our solar system. Stellar nurseries are not just the birthplaces of stars, they are the cradle of the universe. As we continue to explore these fascinating regions, we uncover the secrets of our cosmic origins and the interconnectedness of all celestial bodies. The birth of a star is just the beginning of a grand cosmic narrative, one that shapes the very fabric of our universe. Each star that forms, evolves, and eventually dies contributes to a larger story, one of growth, transformation, and renewal. This cycle of stellar creation and destruction underscores the beauty and complexity of our universe, inviting us to explore further and deeper into the cosmos. If you enjoyed this journey through the science of stellar nurseries and want to explore more about the wonders of our universe, make sure to like, subscribe, and hit that notification bell for more incredible content. What fascinates you most about star formation? Is it the sheer beauty of these nebulae, the processes that lead to a star's birth, or the cosmic cycles that follow? Share your thoughts in the comments below. And remember, the universe is vast and full of mysteries waiting to be explored. Thank you for joining us on this cosmic adventure, and until next time, keep looking up